Hello everyone. Let's take a moment to appreciate the fact that we could change the declaration, one of our function declarations, without having to screw up everybody else's code that we've already released to. They can now call our drivers just like they did before, and we give them an optional new parameter without them having to absolutely change nothing. Let's get into it. So what are we talking about? We're talking about C++ default parameters. It's not something you can do in C. You'll know it right away when you see a function declaration with an equal sign in it. And basically what it means is your function arguments can be defaulted to a value right in the declaration itself. So why would you want to do this? Well, one of the reasons I love to do it is you have an existing code base and you need to add an additional function argument for maybe some future or some upcoming capability, but you don't want to have to rewrite or refactor your existing code base so that this function can still be used. Now, I know you could write another function and overload it and have more parameters, but what if you don't want to do that? What if you just want to keep it clean, keep it simple? So what you could do is add the additional argument and then just default it to something. And then your existing code will still work and your new code can take advantage of the new argument. And inside the code, you might have to, check for that, but usually it's a pretty trivial thing to change. So let's go over quickly what this is. So basically a default argument is a value assigned to a function right in its declaration. So keep a small number of arguments, but then have it expand out as you need to without having to fill out each optional argument with nulls, something you'll see a lot in operating system calls in Linux because it's written in C, that you'll have this long list of arguments and it's like, oh, I'll null this one out, I'll null this one out. You don't have to do that with C++. There's a few simple rules you must follow. One of them is you have to put those initialized parameters on the far right. Some of the other rules you have to follow is that it has to be defined in the function declaration. So it would be in the header files. If you put it in the definition and you put it in the declaration, the compiler is not going to let you build it anyway. So it goes in the header only. So you will not see it in function definitions unless the function definition is all you have and it's in a class, but that's for another time and another day, that story. So we put them in the header. The advantages, it helps to avoid function overloading. The end result is you support backward compatibility and it extends your existing function signatures. So I'm going to spin up Eclipse and I'm going to show you a quick example and you can see how this can be useful. Be right back. All right, I'm back. Let's take a look at our sample code here. We have a function called connect to server, and we're just going to pass in an address for an IP string. And inside connect to server, we're going to just simulate that we're actually connecting to a server, but I will output to the console the timeout value, which I have set here as a constant. Pretty trivial program. I'm going to run it. I'll show you. Right here we see it ran, ended, and it tried to connect with the default timeout of 5 seconds. Now, let's say we wanted to make that argument not constant. Let's say we want to be able to pass that in at runtime. We want to say, hey, what if I want to connect with a 10-second timeout? Okay, the first thing I want to do is add an argument here called const. We'll just use the same name again. Declaration and definition match. So we do something like this. Now we would get rid of this. So basically we just moved it up into the declaration. Now this will not build. Okay. And it makes sense. Too few arguments, yada, yada, yada. Well, it makes sense. There's only one argument here. This is your existing code base. So this right here, maybe you might have hundreds of calls like this. And you're like, I'm not going to go back and change all those. Now you're thinking, well, I could overload it. I could make a new function and but now you got to duplicate the code that's inside these functions. You have a big copy and paste issue. And you can do that. And in the C world, you probably would do that. But we're not in C. We're in C++. And we get to take advantage of all the things that it gives us. So all I got to do is assign this a value of what it was before. And look at that. It builds. And if I run it, we have the same result we had before. We didn't have to refactor large amounts of code. All we did was add the equal sign right there. Now, this is just one of the advantages to doing this. If you're starting from scratch in your architecture and you're using C++, you could build this in right up front. And the only thing you have to remember is you want to keep all of these the right-hand side of all the arguments. If you try to put this first, the compiler is going to bitch at you. You know, let's say we did that, and I got to swap this here too. It's not going to work because it fills in from left to right. Okay, so we have nothing here. So well, let's say we had a value here, and this probably won't build anyway, but yeah, it didn't build. But the compiler is letting you know, like, you cannot do it this way. So let's say we had it like this. Okay, now it built. Now we wanted to make this first argument, we wanted to make it, you wanted to give it a default initialization. It's not going to build. In fact, the error will be, let's take a look. Yeah, default argument is missing. It's going to catch it for you. So the main thing to remember is, well, there's two things, and this will get you through most stuff. Number one, you want to put it in the declaration. Put it in the header file, put it in a declaration, and put it to the far right, work your way left. Okay, so you can't have anything in between. Your default parameters are always going to be on the right. You'll right away, if you've ever worked with Linux or worked with operating system calls, where you see a whole list of arguments, not just two here. And then when you look at examples, you'll see that some of them are just made null, which means, oh, ignore it, which is fine. And you can do that, but then you're going to have a long list of arguments and it gets kind of messy. And then you would null out the arguments you're not going to use. So then it never changes. But that means you know right up front what your calls are going to be. And then if you make a change to the API, oh, I got to add it. Now I got to add another function call. And if it's in C, you got to rename it because you can't have the same function name. You know, I see this a lot in Linux. I love Linux. I love C. But sometimes I just wish that Linux would convert to C++. So Linus, if you're listening, sorry, but that's just how I feel. One other thing I'd like to add before I close out is, let's say you're passing in an argument like timeout, or you're passing in an argument that you're not going to use. You would have to handle that in your function. You know, let's say you had if some kind of use seconds instead of milliseconds. Okay, and we made that a bool, and the default is false. Internally of the function, we would have to validate something like this to make sure that we handle it properly. All right, so, you know, we added this. You know, you add these booleans, you want to activate a certain function, something that might have been nulled out, which is why I made equal to false. You just have to make sure you handle it. It's really obvious once you start using these default arguments, you're going to see where it's like, oh, I'm not using it here, so I have to make sure I skip over that. But basically, it's not hard to do, and this is just one example. So anyway, that's all I have. You know, feel free to beat me up in the comments below, and see you on the next one. Thank you. Have a good one.